So now what I would like you to do is, now that we just covered r equals a cosine theta, we need to see about r equals a cosine theta. We need to discuss r equals a sine theta. So what I want you to try right now on your own is graphing on a polar curve these two polar equations. And the way that you're going to do that is for what we just did for r equals cosine of theta and r equals negative cosine theta. So you're going to make a big table of values, and then you're going to try and plot it on the polar curve and see what you get. Okay, so let's get this onto the polar plane. So r is theta, r is 0, theta is 0. So we're at the origin there. R is 0.5, theta is 30 degrees, so that's going to be right about here, and I'm going to go all the way to 90 degrees. What we've got going on is half of a circle. If you finish the circle, keep going. If we plot R is 0, theta is 180 degrees. So at 180 degrees, it's back to 0. So all in between, we've got this circle. So sine of theta, remember, sine is like the y coordinate. And y goes up and down. From the center, we've got a circle with a diameter of 1 that's going up. R equals negative sine of theta, so let's check that out now. So here's the graph for r equals negative sine theta. Here are all the points. If we were to graph this on the polar plane now, we're looking at what is r as theta moves. So when theta is 0, r is 0. Okay, center origin, okay. When theta is 30 degrees, r is negative 0.5. So let's convert that. Negative 0.5 of 30 degrees. It's going to be 0.5. Now we have to add 180 to that. That's going to put us at 210 degrees. So 0.5 radius, 210 degrees. That's going to put us down here. Next, when theta is 45 degrees, r is negative 0.7. So that's going to put us at, we got to change that to 0.7. So we have to add 180 to 45, that's going to put us at 225. So at 225, r is 0.7. Then 60 degrees, negative 0.8. Got to write it as r is positive, so that's 0.8. 60 plus 180 puts us at 240. 0.8. Then 90 is negative 1. So 1 comma 90 plus 180 puts us at 270. Notice that is half of a circle, but now it's below the x-axis. If you finish up the rest of the points, you're going to see that we just have a circle whose diameter is 1. It's tangent to the line y equals 0. It faces down. So here's a little bit clearer of a picture. R equals sine of theta is the red circle. R equals negative sine of theta is the blue circle. Now, what do you expect to see if I put a coefficient of 5 there? What would you expect to see? What would be the orientation of this circle? And what would be its diameter? Think about that. Now I'm going to graph it. And there it is. Let's do one more. Why don't you think about r equals, why don't we say r equals negative 3 sine theta? Think about that. So let's check and see what r equals negative 3 sine of theta is going to be. And so that's the one in purple right here. Okay. It's going down by 3 units here. See that? That's the diameter of the circle. So now let's wrap up r equals a sine theta. So for all polars of the form r equals a sine theta, when a is greater than 0, you're going to have a circle that's tangent to the line y equals 0. Okay, think about this. Sine is the y coordinate. Okay, notice it's opening up from the center. That is a length of A. If A is less than 0, it's opening like this. Now when I said length, it's really the diameter. It's got a diameter of the absolute value of A. So what you need to be able to do is recognize that when you see r equals a sine theta, what you have is a circle. And you are responsible for, if I say to you, draw r equals 4 sine theta, you need to be able to draw that. So we know it's a circle. We know it's going to have a diameter 4. And there we go.